Find the particular solution to the differential equation y double prime of x plus y of x equals 2 to the x. So they provided the independent variable x explicitly. They didn't have to. They could have just said y double prime plus y equals 2 to the x. But nevertheless, we will evaluate yh for y homogeneous, which equals y double prime plus y equals 0. And we need to find our homogeneous roots, so we use our auxiliary equation and have r equal to the amount of derivatives being taken on y. So y double prime is r squared plus 1 equals 0, where there is no derivative on y, so we leave the coefficient by itself. And now, moving 1 on the right-hand side, we have r squared equals negative 1. So r homogeneous equals 0 plus minus I, where there's no real number being added to I, and that means that alpha equals 0, beta equals 1. This gives us our homogeneous solution, yh equals c1 cosine of t plus c2 sine of t. We get rid of the e term since e to the alpha t is 0, which should have been multiplied by everything, and beta is 1, so t stays by itself and is unchanged. Moving to the important part, y particular, it usually will follow the general format ay double prime plus by prime plus cy equals c times the independent variable x, usually I use t, but I'll keep it as x in this case, to the power of m times e to the r particular times x, where a, b, c, and capital C are all constants. M is the power of the independent variable x, which we don't have here in this case, and e to the rp is the particular root of this problem, which I'll get into in a second, and that's just being multiplied by x. So we have an interesting term here where we have 2 to the x. We can break that down over here as y double prime plus y equals e to the ln, and we know that e to the power of ln cancels itself, of 2 to the x. Using the log power property, we can move whatever's in the exponent as the coefficient, which is the same thing as moving it over here if you want. So this will equal e to the ln2, a constant, times x. Now it's more obvious to us what rp is. Rp equals just ln2, whatever's in front of the independent variable x. And we know that Rp does not equal Rh now, since Rh was 0 plus minus I, so this means that S equals 0, which I'll get into in a sec as well. But we should also know that M equals 0. Since there's no x outside of this is some version of E, if you will. Now we'll know that y particular takes the general format of the answer t to the s times a decreasing polynomial of power m, so a sub m times t to the m plus a sub m minus 1 times t to the m minus 1, so on and so forth until a sub 1 times t plus a sub 0 will be multiplied by e to the rpt. And we don't have sine or cosine, which would take a slightly different form, so we don't have to worry about that. And we know from before s equals 0 and m equals 0. So plugging that in, yp equals t to the 0, and we can get rid of any m term here, including a sub 1 times t, since there's not even a single t, which leaves us with a sub 0, e to the ln of 2t, as rp still equals ln2. Rewriting that, yp equals 1 times a sub 0, e to the ln2t. Also, I forgot to mention I'm letting t equals x because this is the general format I like to keep. Anyways, we need to take two derivatives of this to allow us to plug this back into this x or t equation. So yp prime equals, we move the ln2 in front since this is an exponential term, and we have to make sure a sub 0 stays there as well. So it would just be a sub 0 times ln2 times e to the ln2t. Doing the derivative one more time, yp double prime equals a sub 0, and e's will just always stay there. So bring another ln of 2 out, so a sub 0 times ln squared of 2, which is equivalent to ln2 squared, times e to the ln 2 of t. Now we can plug this back in to the equation y double prime plus y equals 2 to the x. So for y double prime, I'll return it back to the x format since they're being set equal to each other. So y double prime, which we found to be a sub 0 ln squared of 2 times e to the ln of 2 times x, or t again, plus y, which is a sub 0 times e to the ln 2 times x, equals e to the ln of 2 times x, which is the same thing as 2 to the x. So what can we do to find the undetermined coefficient a sub 0? Well, we can first factor out some common terms, that being a sub 0 and e to the power of ln 2x. So bringing those out, all that's left in this term is ln squared of 2, and all that's left in this term is just 1, since we already pretty much took everything out. And that equals our right-hand side. Now our goal is to isolate a sub 0, so we can divide everything by whatever's being multiplied by a sub 0. So e to the ln 2 x times ln squared 2 plus 1. Fortunately for us, all the e terms cancel, which leaves us with a sub 0 equals 1 over ln squared of 2 plus 1. And that's it. So going back to our yp original formula, that equaled a sub 0, or 1 over ln squared of 2 plus 1, times e to the ln of 2 times x. And that is our answer to this problem. And for the sake of showing what the entire solution should be, y general, I'll just add it on the side here. This equals yh plus yp equals c1 cosine of t plus c2 sine of t. And we just add whatever we had as yp. But all you have to do is answer this equation. And remember that I'm also using the t's and x's interchangeably. So hopefully this helped you understand the problem a little more. If it did, please like and subscribe, and I'll see you in the next video.